All right. Hello, everybody. We're recording now. Let me display the agenda. See if this works. Okay. All right. Thank you, everybody, for joining today. This is the Nephio SIG Automation meeting for August 10th. And just sorry about all the calendar issues. I don't know what's going on, but we're going to move anyway off of this tooling, I believe. So the next meetings will be on Zoom, and probably we'll have a groups.io calendar. So I don't know, you'll just subscribe to it, whatever calendaring tool you use. So announcements. So the TSC met. Most of you, I think, were in previous calls, and they merged SIG platform and SIG automation machinery, and I'll be chairing this new SIG called SIG Automation, which this should say SIG Automation, but that means that there's no meeting tomorrow. We don't need another meeting, so one less meeting on your schedules, which makes me happy. There is a vice chair election going on, so we need a vice chair for this SIG. And to nominate yourself, go to that link. It's right there on the agenda, and you can add yourself in there, and the TSC will choose the vice chair. I believe I think we have another week or two before they do that. And like I already said, the next meeting will shift to standard Linux Foundation tooling. So I will stop having to admit people every few seconds to the meeting. Any questions before we go to the next agenda item? I have prepared a sort of proof of concept demo I'd like to go through, but just before that's going to take a while, and there's probably going to be a lot of questions and comments. So I expect that's all we'll get to today. So, anything else we want to cover before I jump into that? Hal.
So this might be a question for all the SIGs. How do you imagine this co-chair arrangement working? Sharing responsibilities, or like, what do you see the role of chairs in these SIGs?
That's a good question. I think that's more of a TSC question. I mean, I can tell you what we do in Kubernetes, and that's my mental model. In Kubernetes, we have co-chairs. We don't have a chair and a vice chair. I think in theory, a chair and a vice chair are slightly different, right? Role-wise, I think that we also have a concept of a SIG TL in some SIGs. And some, the chair serves as a TL, and the chair and the co-chairs all serve as TLs as well. So part of it's just administrative: run the meetings, keep the agenda, move the ball forward, and then that TL aspect is sort of responsible for technical decisions. Obviously, it's a community. We try to sorry, your video, your screen's over here. My camera's over there. We try to do things by consensus as much as possible, but sometimes that decisions have to be made, and in theory, the chair might have to make that decision, or the vice chair, or whatever. And if people can't agree, then it goes up to the TSC. So That's how I see it. What about what's your? I mean, I think it's still to be determined to some extent.
Yeah, it sounds like a lot of this project is we're working it out as we're going along. I think that's fine. I just wanted to ask because we're asking for people to start submitting nominations. So it's what are they actually signing up for? But to an extent, it seems like the chairs will define their roles too. I see it more as it's not so much about making decisions or if we get to a point where in the community there's say two camps over an issue and it becomes something that needs to be voted upon, or we can't reach a consensus, then that's a problem. But
I hope that's right.
Yeah, I see it as leadership role of, as you said, setting the agenda, setting the tone, and not necessarily making decisions for the community. The community decides together, but as we know, in a lot of these projects, 90% of the ability to make decisions is showing up, being at meetings and proposing things. Whoever does that gets to set the agenda. So, and the agenda is open, right? Any contributor can put something on the agenda. I don't think
absolutely
the chair would say no to somebody putting something on the agenda. So at the end of the day, it's really an administrative / leadership role, as I see it.
Yes, that's fully aligned with what I'm saying. We'll see what the documents say, right? That's what the TSC is going to work. They're modeling it after Acrano, so I'm not actually that familiar with Acrano, but I think Acrano was partly modeled after CNCF. So it's like all of these things, are sort of self-referential. We'll see. There's a draft out there if you want in the TSC. In the TSC Drive folder, there's a draft for the policies and things. I haven't looked at it, but it was basically clone of Acrano. And so that should, to some extent, scope those roles. I think from a time commitment standpoint, I mean, I expect to spend a substantial amount of time on Nephio, and as a chair or vice chair, the expectation would be it's a focus item for you, and you're closely in touch and leading, like you said, and guiding the community in the direction and trying to herd the cats towards actually releasing some software. So that's how I see it.
Right. So in a strict technical way, if it's it could be that chairs would rotate in terms of leading meetings or something like that, or I don't know. I think maybe even every SIG would figure it out on their own what the best way to work is.
I think to some extent, yeah, but definitely you need, if one person's out, there needs to be somebody else to run the meeting. Of course, you can always delegate it to somebody else if both people are out, right? It's not such a
yeah.
But
okay,
awesome. Any other questions before we jump into what I've got here? Okay, awesome. So then let's do it. So I have a sort of intro deck here. All right. So starting with the goals. The goals here are to demonstrate sort of one part of the package lifecycle and workflow that we expect Nephio to enable. It's to demonstrate how we can use a controller for provisioning these workloads, and to identify gaps in the underlying components for controller usage. So some of these components we've talked about, like Porch, which is sort of kept as a service, is the team building it is focused on a UI experience and on a CLI experience, a GUI experience and a CLI experience, and Nephio wants to use it with a controller. And so that's a different set of problems potentially. So there's that. Demonstrating per cluster customization of a workload based on context. So what I mean by that is, and we'll see in a minute, you have some workload, you want to install it across a fleet of clusters. There's some contextual information about each cluster that there's some contextual information about each cluster that needs to be ingested into that instance of the package or that variant of the package or workload. Explore the use of a CRD as a contract between the controller and the package. So one thing I want to be sure we're careful about in how we build our automation controllers is that they don't have to understand the package. They don't have to know anything specific about the package. And so the idea is that, and we've talked about this a few times, that a package can advertise an interface, an API effectively, that says, here's a way in which you can interact with me or manipulate me or automate me. And a controller then that understands that contract or that package or that interface or that CRD can then, any package that advertises that interface can be managed by that particular controller. So we're not tying the controller and the package really directly together. We're using some common interface that can be used across many packages and many controllers potentially to create that interaction. Specifically, we want that, or specifically in this instance, the way that in the package process, the way that interface is implemented is through a kept function. That kept function should also not be package specific. It should be associated with resource types. Resource types exist across many packages. A deployment is a deployment is a deployment, regardless of what workload configuration package it's part of. And so we should be able to build a function with semantics that understands how to do things with deployments, rather than having that function understand a particular package. So that's also something I'm exercising here, and we'll see this in more detail later. Some non-goals for this POC. I'm not focused on the infrastructure side at all, or the connection between the infrastructure and the workload. Those are important things that we're doing, but that's not part of this POC. I'm also not looking at the runtime configurations via an operator. So we'll look at the package lifecycle in a second. The stuff Steven's working on and we'll demonstrate at some point. I'm not sure when exactly he's here. He might be able to fill us in. We'll really focus on that operator side. So this one does not do that. All right, so let's see the next slide. Okay, so is that, yeah, that's pretty visible. So looking at, this is a, quote, typical package lifecycle. There's variability in it, but this is sort of illustrates some of the pieces. And we'll walk through this, and then I'll explain why I'm walking through it. At some point, there's initial authoring. So in our scenario, we're looking at sort of COTS software, so commercial off-the-shelf software, effectively, vendor-provided software. They're going to author some package that represents their software, and they're going to put it in a public catalog. Then a organization that's a customer of that software vendor will clone that package into a private catalog, draft branches in there, meaning the catalog. Remember, these are Git repos, these catalogs, these cylinders here, these magnetic disk icons. Those are Git repos. So they have branches, and the draft branches are where you're sort of iterating on something that's not quite ready to use. So you're going to clone that. You're going to iterate on. I didn't really draw this. There should be a line probably with showing humans executing iteration on top of that, and adding in their organizational policies, things like that. Yeah, Wim.
So, John, I have one clarification. If you say public catalog, are you referring to a package?
I'm referring to a Git repository that has a list of packages in it. So think of
okay, just to no, I just want to clarify, but yeah, I understand.
Right. It may not be public. It's just to differentiate. It could be vendor catalog that they only allow their customers to access. And it's got all of the Nokia packages for all of the different software that Nokia sells, and then customers can come in and pick one and pull it out of there. They take it, they customize it for their environment, they add in their organizational policies, they add in information about, maybe they say, well, we want this pod to have some sort of anti-affinity policy, right? Like they might add things in for their own reasons and customize that package to their environment. Then they publish that, and it goes into their private catalog. So this is sort of the network designer or the designer persona, or platform team persona in enterprise, we tend to call it. And then there's the deployer persona, who's going to come in and pull things out of that private catalog and follow exactly the same process, but their destination repository is a deployment repository. So the difference between a catalog repository and a deployment repository in this model is that a catalog repository contains blueprints or packages that aren't ready to be instantiated on a cluster. They're missing stuff that they need in order to actually run. Like there are specifics about the environment in which they'll be running that aren't there. Now, you might be able to take it and run it just as it is, but it's not expected that you could. Whereas a deployment repository is actually a repository that config sync is consuming things from and pushing to the API server. So that your GitOps tool, if it's not config sync, if it's something else, is pulling things out of that repository and pushing them directly into the API server. So it's fully hydrated is the terminology we tend to use. Like hydration process being taking it from a dry, or which kind of refers back to don't repeat yourself. So like Helm charts are typically dry, to a fully wet or fully hydrated, realized configuration. So eventually that's what this whole process is intended to create, a bunch of values sitting in resources with values on them sitting in a Kube API server. That's the ultimate end goal. So, okay, so during this stage, I can't see my cursor. You can't see my cursor either, can you? That's really annoying. Now you can. Oops.
John, I have one more question, if I may.
Sure.
So when you draw the controllers and humans on top of the deployment repo, so basically, what do you mean with that? Is that to go from this blueprint packages to get to deployment, there is a set of controllers that basically manipulate the context in order to get to a full deployment ready package?
Yes, exactly. So controllers here, and you'll see, because we'll see in my demo actually, these deployment, the private, I don't use the private catalog, I skip those steps. I just go from public to deployment. But my controller will fan out and create multiple instances of the package for different deployment repos, customized to the particular cluster that's consuming those.
Yeah.
So
because the repo that I saw, I had a look at the code, right? What it's basically doing is taking the content of the, let's say, deployment repo based on the configuration, and then making sure it's replicated to all the clusters with which will be consuming them, right? So I would draw the controller a bit in relation with config sync if I would. So you see what I'm saying?
yeah, well, I mean, I'm just trying to, like, there's too many.
I was trying to, yeah. Sorry.
Yeah, I'm just trying to, like, this is like an instance of a single. I'm trying to emphasize here, the reason I drew this actually wasn't for this presentation. I drew this for a different reason, and if you go to that issue down there, you'll see. I'm trying to identify, each of these gray boxes is trying to identify places in the journey in which mutations to configuration can happen. And okay. The reason for that is that we want to identify, we want to communicate, we want to figure out when should you use what mechanism, like what mechanisms apply in each of those stages, and what's the appropriate type of change to make in each of those stages from a best practice perspective, and what are the pros and cons of using each stage to affect that. So I don't want to go too much off on a tangent, and we can come back to it. I mean, because there's a lot kind of to cover. so
Oh, we can take it later if you want, because the way I look at it, at the controller itself, for me, if I look to the drawing, but it's really maybe a drawing thing, it's actually, you could see it as the way that basically is a controller that takes the blueprint and makes it to the deployment. But I think in what you're actually doing is it's the controller that actually replicates the configuration, which and makes it available to config sync to consumers.
yeah, like this drawing, like really this clone operation in my talk is done by a controller. So
Okay.
it doesn't really accurately reflect, actually there are controllers. The controllers and humans that kind of can be involved in any of these gray box stages. So it's not really great drawing. It's a start. But there's
I was just trying to clarify the drawing just for people who are a bit new to it. Okay, that's
it's great. Clarification is good. The controllers here that I'm thinking of, this is like here, for example, you could have a controller that goes out to an IPAM system, allocates an IP address, and injects that into the config. And then, right, so,
which I would say it's a different different kind of controller. That's why I was trying to make a distinction. Why I made a bit the question or the clarification, because I see different set of controllers in that phase.
Yeah, you're absolutely right. Yeah. Okay, so the ill-formed or not fully formed package is going through this journey. At some point, it gets proposed and approved. It gets pushed to a deployment main branch. Config sync pulls it out, pushes it to the Cube API server where it goes through the admission controllers, and then eventually gets realized, there's kubelet and all these things down here, controllers hanging off of here that we don't show. And then at runtime, it can be executed here by, it can be modified here at runtime by an operator. So that's kind of, these are sort of leverage points where we can affect what's running in the edge cluster eventually. And so, as I said, this particular demo is focused kind of on this part here, where we're cloning and we're using a controller to fan out across multiple deployment repos and propose something in the draft branch that is customized to a particular cluster. So here's the setup. I have, and by the way, I'm just using GKE autopilot clusters here because I don't have a bunch of edge clusters and it's not important for this demo. The other thing I wanted to say, if you go read the document, so this is based off this simple scenario document, I basically get through more or less scenario 2, but I tweak it a little bit. But this is not using a telco workload, right? This is focused on this machinery. It's not focused on the telco specifics. The machinery is the same regardless of what the workload is. So I have a management cluster. It's running different components. You can actually learn how to set that up yourself. There's a setup guide here. It'll get that all running for you. There's 5 repositories. One is basic packages. This is equivalent to the public repository. Private catalog exists, but I'm not using it for anything. And then there's these 3. I'm only going to show something happening with the edge clusters. Okay. Links here. I'll share this document after the meeting. Okay, so here's the scenario. And I'll drill into it a little bit. But basically, we're deploying a workload. And we're going to, I've created 3 different CRDs, one to represent a cluster, one to represent something I'm calling a cluster scale profile, and then one that's called a package deployment. So what do these do? The cluster is a way for us to identify what clusters are out there so that we know what to install, where to install things. Each cluster has attached to it a cluster scale profile that provides some demographic information about the cluster. These are sort of proof of concept to illustrate an idea. The actual resources that we'll come out with are going to be different, and they're going to be informed by the network architecture SIG, and I just picked some things to demonstrate the workflow. There's a controller that processes the package deployment. And what does it do? The package deployment contains a label selector. I'll show it in a minute. That is used to find the relevant packages, or relevant clusters rather. It includes a reference to a package to install. And so when it sees that when the controller sees that package deployment pop up into the management cluster, it identifies those clusters, it finds that package, it clones that package to the repository, deployment repository for each of those clusters. And for each of those, it looks in that package and says, does the package have a cluster scale profile in it? In other words, does the package understand this CRD? And if it does, it takes the cluster's specific scale profile and injects it into the package, so that then the package has a function that runs and interprets that and adjusts its deployment and application configuration in order to account for that cluster scale profile. Okay, so I think that's my presentation, and let's go to actual stuff. How do I want to start? I can start a little bit. So there's a few problems we have to solve along the way here. And one is there's two things we want to adjust when we customize a package. When we customize a package for a given scale profile. Why don't I show you the I'll show you the, is that too small? Can you see that?
That's good visibility.
Show you it's probably easier to look at the So here, like I showed you that drawing, I have a regional cluster, and this is the cluster CR, and it basically just points to a particular scale profile and a particular deployment repository. So this tells the controller, where do I need to install this package in order for you to pick it up? There's some labels on here, the region and the site type, regional. So that's my regional cluster. My edge one has site type aggregation. This one is a small fixed site, and this one's a medium fixed site. So let's see what that means. Again, these are not built to life CRDs, but it's something to exercise our machinery. So a small fixed site says it's not auto scaling. It's got 6 nodes. The reason max is there because if it is auto scaling, you want to know what the max is. And site density low. So what that means is this is like if you read the scenario document, this is sort of like, well, is this site in a high population area or a low population area? Because we're going to adjust the number of DNS instances that we're running based upon the expected traffic flow, which is related to the density of the particular site. It may not be how things are done in real life, but it's an example. Medium fixed site, a little bit larger, site density medium, and then these are just examples. So what we should see is when we run the controller, we should see the edge 1 cluster and the edge 2 cluster getting different configurations based upon the fact that they're pointing at different scale profiles. Okay, so what does the package deployment look like? So package deployment, as I said, what namespace should I install this package in, and give me a reference to the package. I'm going to install and I'll show you these packages in a minute. I'm going to install the coordinate caching scaled from Nephio packages revision 1. And you can see my label selector is saying anything in US Central 1 that's site type aggregation is where I'm going to install this particular package. All right, so let's take a look at those packages. So what I have here is, like I said, the initial setup was the management cluster, and it's running a few things. It's running Porch, which is our sort of API on top of Git that allows you to manage these packages. And then it's running a UI. We have a UI. This is all sort of prototype. This is just a prototype for a UI for on top of configuration as data, which is what Porch is. Nephio would build its own UI, but for now, we just borrow this. Then, well, in theory, the controller runs side by side with this. In reality, I didn't package it as a container. I just will run it on my workstation and it'll attach to my cluster because I didn't have the time to do that. So this particular, we've registered all of those repositories with Porch. So we can see them here. This is the deployment repository for Edge 1, for Edge 2, and then my 2 catalog repositories. I didn't do the regional cluster at all at this point. So there's currently no packages installed in either of those Edge clusters, and we can kind of see that if you run, this just goes through my queue context and just calls a bunch of things. So these are just essentially system level things. So this is config sync. Those are running on each Edge cluster, not as a package installed via their repository, because that would be circular, right? I just manually installed the package, and if you go to the setup guide, you'll see how to do that. I haven't, by the way, I have the setup guide. It kind of peters out on actually building out this demo. It gets you to like the setup, but not past that. Sundar, yeah. Go ahead.
Yeah. Hi, John. I understand this is a POC or more like an example, but are we actually proposing there'll be a single CRD, like package deployment, which will describe an entire deployment by itself?
This is an example. So the idea could be, think about, it's a great question. So if you think about, the analogy I use is the workload controllers in Kubernetes. So in Kubernetes, we have a few different workload controllers. We have deployments, we have stateful sets, we have jobs, all of these batch type workloads. So those are all examples of workload controllers that core Kubernetes supports. Similarly, we would have different controllers that are part of Nephio that handle different types of scenarios. I don't know what those are yet, and this is help we need to figure out together. We need help from the network architecture group to understand those architectures and what's materially different. So if you think about the workload controllers in Kubernetes, there's a material difference between a deployment and a stateful set, in that a deployment is working on effectively stateless workloads, and a stateful set is more complicated and handles maybe some percentage of the case for stateful workloads. Then there's custom operators that people build for their specific applications or specific workloads that know how to do more than those basic primitives. And so very analogously, I see this. This is a not real world example of the kind of package controller we could build, but I don't know yet what a real one looks like, and I don't know how many there will be that are part of core Nephio, but others can also come in and add new ones. And yeah.
Got it.
Okay,
Thank you.
Question before I go to the next.
Yes, it does. Yeah. The multi-cluster deployment, of course, be much more complex than a single cluster controller like deployment of stateful set, right? So, for example, you may have different policies or options for let's say deployment one cluster failed, would you roll back your previous deployment to another cluster for the same application, etc.? So all those things also come into the picture.
Right, and yes, that's a great point. There's also a rollout, or just a progressive, what I refer to as progressive rollout, meaning I've got 1,000 clusters, and the deployment. Yeah, it failed. You roll back, or you deploy it to 1% of the clusters, and then you deploy some monitoring tools, and those monitoring tools provide feedback loop into some metric service, and then your workload controller, or your package controller rather, looks at that and says, okay, the signals I'm getting back from that 1% of clusters looks good. I'm going to go to 5%, and there's like 1,000 things we can do, and we have to figure out what those are. Yeah.
Yes. Okay. Sounds good. Thank you.
Yeah. And
Hi. First, totally agree with your comments about extending this in the future to include other things. And piggyback on that is because I come from Marvell and we do DPUs, right? And one of the things I'm struggling with is the controller that deploy not only the workload, but possibly the infrastructure configuration for DPU or XPU, IPU, GPU.
yeah, so I think I recall you joined late. Like, I'm not trying to address infrastructure in this
Okay.
demo.
Okay.
That's like, it's too much, right? I'm just trying to.
Yeah. No, I'm hoping maybe we can talk in
That's
future session or
very
something.
much in scope for Nephio, and that's a big goal we have. There's a lot of work we have to do to get there, but that would be amazing.
Okay, and then second point is really quick. Actually, I'll yield. I'll post it on Slack or something.
Okay, yeah. I mean, or maybe if we have time at the end, we have 20 minutes, so.
Sure. Thanks.
We're getting close to the demo. Okay, so let's look at this. Where was I? Okay, so the packages. So we have none installed in the deployment right now. We have in our catalog repo a few things. So as I mentioned earlier, there's a setup guide for how to do this. These packages are used in the setup of this. So the Nephio config sync, Nephio system, Nephio web UI. This package actually is what we're looking at, right? It's that running on top of this. The Nephio config sync is running in each of the edge clusters. So we have two packages. There's the CorDNS caching one, and then there's the CorDNS caching scaled. So let's look at the difference between those. So this is the scaled one. We can look at it in comparison to its base blueprint. So, well, I guess maybe we should look at the base blueprint first, so we know what we're talking about. The base blueprint, very simple. It consists of a deployment, a service, and a config map. And this is metadata, right? So like I said, very simple workload. The deployment is a very standard deployment. It mounts a config map, and then the service is just on top of that deployment. So if you look at the config map, this is the config map. It's got one key. That key is the core file. So in CorDNS, it's very simple. It's just one configuration file in a caching configuration like this. Completely stateless, right? I'm trying to simplify for the point of this. So a few key things, though, that we do need to think about, that even with this super simple package, when we're installing in different environments and we want to scale this package, there's two things we need to do. We need to adjust the deployment. So in order to do it, we want to adjust the deployment. Let's look at the YAML here. We want to adjust the resource limits, and we want to adjust the replicas, which I don't see on here, but it should be somewhere on there, or maybe it's not included and it's expecting to auto scale. I don't know. But here's the interesting thing, and this is like what I'm trying to do again with the demonstration and the proof of concept is sort of flush out the concerns that we're going to have. So when we're going to say scale, which is a very common operation across many different applications and packages. Very commonly, we would scale the deployment, but a controller that doesn't know anything about the package isn't going to necessarily know the details of what you would want to do to that deployment. So the example here is that with this simple DNS service, you can't just vertically scale the pod and have it perform better. I can give this 10 CPUs and it won't perform any better than it will with one CPU because it will saturate the NIC with one CPU. So no point in giving it 10 CPUs. So I know that as the package author understanding this application, but a controller wouldn't know that. So a controller can't just sort of automatically go, I want to scale it, I'm just going to bump up the number of the vertically scale the pod. I need the package to have to be able to respond to a signal from the controller saying, I need you to scale to some capacity, some measure of capacity. And the package needs to know how to do that. Secondly, the package has its own application config. If I scale, this is a caching service, if I scale this service memory, but I don't change in my config map the size of my caches, then I'm not going to use that memory. So as an application author, or rather a package author, I know that if you give me this much memory, I can increase these caches this much. And so, and again, also similarly, I might increase the number of concurrent connections that I can manage upstream. So these are the kind of considerations that a controller shouldn't, in order to create a generic controller or a more reusable controller is a better way to put it, the controller can't import package knowledge. And similarly, to create sort of packages that aren't tied to a specific controller, the packages shouldn't import controller knowledge. And so what we need is some sort of interface between them. And that's what the cluster scale profile is. It's an interface between them that could be used in multiple. It may not be maybe a capacity profile would be a better one. Like there's probably a better abstraction with that profile than cluster scale. Yeah, Tal.
So just to point out, it might be obvious, but it's, if we do want to think of something like Nephio generically handling scaling, it's not just how to scale, but it's the whole loop, right? It's when to scale as well as a policy or algorithm that's specific, which metrics are needed, etc. So I wonder what would be, I'm thinking out loud here, but what would be the value of, say, having this notion of scaling, general scaling in Nephio? I mean, it could be a way to say, define certain modalities, right? Because again, we're in a declarative orchestration environment, right? So it's not, scaling, we don't think as an operation that anybody is initiating, like please scale. We expect these systems to self-heal and self-scale, right? As necessary, right? There's some sort of control or monitor that will scale when necessary, scale up when necessary, and scale down when necessary, right? So, if we are thinking of Nephio kind of managing scaling in this way for disparate workloads that work and scale very, very differently.
So let me just pause there for a second.
Right.
The reason I brought this slide up is there's two different kinds of scaling. There's auto scaling, which is what we typically refer to as auto scaling, which is happening down here in this runtime environment. And there are places where you may or may not want to auto scale. Like you may not want to auto scale in environments where you have a very small fixed number of resources because you want to have tighter bounds on resource consumption. So what I'm talking about right now, and scale may not be the most common operation here, but is up in the config pipeline. So we have multiple areas, like I said earlier, points at which we can affect the configuration. Now, there is a broader, and they have different latencies. Like the one down here auto scaling can happen within a minute or two, right? Whereas this broader one, if we go zoom out from this, there is in the original Nephio slides, you'll see a feedback loop controller or something we call it, control loop. And that's what you're talking about, like to go through the configuration cycle. So this is where I get back to, we need to figure out the best practice of what operations and what configuration changes are appropriate at what level. Auto scaling is great in some cases, but not in others. Also up here, you have the advantage of a human can review this, or you've got this discoverability. You can look ahead of time before it fails out when it gets to the cluster. So there's we have to sort that out exactly when to do which operation. But your point's well taken. And there are other approaches to solving the problem of quote scaling, and there may be different times to do different things. Yeah.
So, oh, okay.
Sorry, Kyle.
Can I follow up quickly on
Yes,
is that okay?
sure.
So I set myself on the agenda for next meeting to give a presentation that I think will hopefully complement this. But here's the issue, right? I think you're presenting scaling as an example, right? It's just an example of reconfiguration, of day 2 reconfiguration. And there can be all kinds of reconfigurations for various purposes, right?
Exactly.
Some of them might be reconfigurations at the network service level, right? If you, for example, slicing is one of the big ones. Right? So you need to reconfigure your network functions to enable that. So it's not necessarily about scaling, it's just about changing your mode.
Right.
But here's the thing, it's so broad, you can think of scaling. So what is a reconfiguration, right? Configuration itself is very, very thick. So you can have, changing the config map for an application.
Right.
It could be, as you said, in this case, we need to, say, add another SRIOV pathway.
Right.
And suddenly, reconfiguration can mean, this pod, because of its affinity and requirements, can no longer run on this node. It actually has to move to another node.
Yep.
Right. So we really need to think of this extremely broadly, right? In terms of, it's not just config. It's not just config map resources and restarting pod.
No,
Yeah.
It's bigger than that. There's the application config, then there's the infrastructure. I'm not trying to address infrastructure, but we could go there. And then you're talking about potentially a composed set of packages. Like it's going to get huge, but I'm trying to start small.
Yeah, no, it's good. I'll try. Hopefully next time, if it fits the agenda, then I'll try to organize my thinking on, and
awesome.
Maybe for all of us about this. We'll see.
And we're running low on time. Is it a quick question? Because I want to get to.
Oh, sure. I just follow up on Tal and the other gentleman earlier. It's about multi-site, right? It's not just multi-cluster and scaling out, but
right.
There's the concept of network slicing and multi-site sites. That's all.
Okay. Yeah. Well, so let's try. I guess I'm running on time. So let's look at the difference between these two packages. So what do? I introduce a few things. I can compare it back to that other. I should be able to. It was working a minute ago. There we go. I can compare it back to that. And so you see, I've added a couple of things. I've added a cluster scale profile. So this is essentially saying, and it's just a sort of default. We have to show the YAML view here. It's a default with just a few things in it, that if the cluster that this is being installed on by the controller doesn't have a cluster scale profile, this is what will be used. And then I've added a function configuration. So I wrote a kept function, and what the kept function does, it interprets that cluster scale profile, and it affects change. So this is the configuration for the function. This is the input to the function. And what it's telling the function to do is it says, read this particular profile, that's a name, the one we just looked at. And when you do, loop through, find this config map. Okay, again, I don't want my function to be package specific. I want it to be able to be reused across different packages. So it needs to be very sort of configurable. And okay, this is super crude, right? This isn't what you're going to want to do, but it works in our situation. Is we have our scale profile has low, medium, and high. And so I just create 3 configuration files for the one for each of those phases. So low has a certain number of cache and a certain number of concurrent requests. Medium bumps it up, and actually large, I think, stays the same because we're sort of hitting limits of what's useful. So what the function does is copies the right one into the key that's going to get mounted in the pod, into the core file key. So that's a very simple way to manipulate a config map. It's super crude, but it's what we can do right now in a POC. Secondly, it goes through and finds this deployment, and you could list multiple here if you had multiple different deployments in your package, and sets these values. I actually didn't implement this yet, but I'll show the concept. For the low density sites, it sets replicas to 1 and sets these resources for this container. For the I don't know why that scroll bar looks so weird. For the medium density sites, it sets replicas to 3, bumps these up a little bit. That's basically the realistic limit. Like I said, we can saturate the NIC. So at the high density, that doesn't change, but we increase the number of replicas. So we scale vertically a little bit, and then we scale horizontally. A more sophisticated function could take into account some of the other things like the number of nodes and whether it's auto scaling. I didn't implement anything around that. To show you what this config map looks like, you'll see in comparison to the upstream package, this is what the core file looked like. We removed that and we created the 3 different keys: low, medium, high, and the right one will get copied in based upon the context. Okay, so let's actually try running this package now, this controller. So like I said, my controller is not actually running in my cluster. I'm just going to run it manually. Got a lot of junk. All right, it's going through. All right, it takes a minute because it's probably pulling some. Okay, boom, 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 boom. Okay. All right, I think it's done. So if we go back here, let's look at what it did. Go back to our repositories. Aha, now in each of our clusters, we have a draft. So a draft, this is where this is this collaborative human controller thing. The controller's proposing a draft. We could write another controller that automatically approves it or validates validates some things about it and then approves it. Right now, the controller is just pushing a draft. It's not even proposing it, actually. If we look at Edge 2, we can see that this is the proposed package that's been deployed, and then it's based upon this upstream blueprint. Again, we can go in and we can compare it. Oh, we should be able to. Why is my UI not working? I'll try that again. It did do this earlier too. There, that worked. I don't know. There's some weird thing there. As I said, it's kind of prototype code. Okay, so this is compared to the one. So right now we've got a chain. We've got a derivation chain. We've got accordion as caching, which doesn't include the scale profiling stuff. We've got accordion as caching scaled, which includes a default scale profile and a function configuration to apply it. And now we've got an instance of that, which is customized for a particular cluster based upon the scale profile for that cluster. So if you recall earlier in our conversation, and sorry, Sundar, we really are short on time. That was a medium-sized one. So we should see in our config map here that it's the medium size. So this is the dash low, dash medium, dash high. So this should match the medium, and it does. 4,096 caches, 4,096 caches, and previously it was low. So the function did its thing, and it copied that. Now we can propose this. We can approve it. And what's going to happen now is this is actually, the UI isn't quite accurate there. I already have config sync installed and running on that edge cluster. So what we should see in my other window, I run this now. Let's see if it worked. We should see it there, and we don't. That's not good. I did do something weird last night when I ran through it, in that I killed that repository. Let me just, I may have confused things. Let me try it with cluster 1. This is pop code. All right. We can see, I didn't show this earlier, these are the repositories in GitHub. And so we should see, for example, in here now, yeah, we see this is what we just pushed 11 seconds ago via that mechanism. All right, let's see if those got deployed now. Oh, actually, it just took a few minutes. So here we've got now that running in the Edge 2 cluster, and we got it running in the Edge 1 cluster. So what we've done is we've deployed those packages customized to that specific cluster based upon that scale profile, and that's it. It worked. So that's my demo. We're totally out of time. Hopefully this creates some thought. Would love to get some discussion going on Slack about this some more. Feel free to drill in. I'll share this PDF. I'll put it on the Google Drive, and it's got links, but they're all there in the Nephio project GitHub, and so we can you can give it a try if you want and you've got the time. So thank you for indulging me.
No, pretty cool. Joy of live demo.
Yeah, it's hopefully starts to build that mental model.
Yeah, sure.
Just
Very
a quick
interesting.
question, if I may. Oh, go ahead.
Sure.
Just
Oh,
it was
sorry.
just a comment about the quality. It was quite interesting, actually.
Go ahead, Ann.
Quick question. Is this, I know it's Google, so I'm not intending to offend, but we may have customer running AWS or Azure. Can we port this, do you think?
Yeah, this is intended, Nephio is intended to be any cloud or
Okay,
or
cool.
not even cloud, right? Like,
Private, yeah.
yeah, all of this. Now I'm doing it all on Google because I'm not going to run an AWS cluster, right, to demo it. So none of this is using. There are things like you could use a Google source repository and use workload identity. I'm not. I'm using GitHub, and I'm using a GitHub personal access token, right, in order to manage the. There are Googleized ways to do it, but none of this is Google specific.
Okay. Yeah, I mean, some of this will have, if I have to port it, I'll have to adjust. But yeah, I just want to make sure the concept transfer or the main components.
We could definitely use your help. So like this is built on these underlying components, but the majority of the contributors to those underlying components are Googlers right now. And so we're doing we would love for somebody to take it and run it on an EKS cluster or something like that, or an OpenShift cluster, Tal, and see it run and see it working in those other environments.
Yeah. I'm prototyping something against OpenShift right now. Single node on my laptop.
Okay, awesome.
Anyway, thank you.
All right, well, we're all done. Thank you, everybody, and let's follow up on Slack.
Thank you.
Thank you. Goodbye.
Thank you. John,